In this third part of the algebraic manipulation videos in Maxima, we're going to talk about the last part of that menu, the simplify menu. And for that, we go back to our interface and we go to simplify and say substitute. So substitute provides an entry form, and it says the old value is x, the new value is y. That's just like a generic reference, right? And so suppose that you have an expression that is x squared or x cubed plus y cubed divided by 2 times x times y. Okay, so that's the expression where we're going to substitute and say the old value is x and the new value instead of, it could be y, but let's change to 2.5, for example. What we're saying is like replace x with 2.5 and say OK. And so the command is as follows: substitute the value, the variable in the expression and the expression. There you go. There's another form of doing it, I believe, like if you try x equals 2.5, and I'm going to simplify it to x cubed plus y cubed. And it does work that way too. So a couple of ways: value, variable, expression, or variable equals to value and the expression. If you need to substitute more than one value, for example, say substitute, you can create a bracket and say x equal 2, y equal 3, right arrow, comma, and the expression, let's say, is going to be x cubed minus y cubed plus z, just to keep some algebraic element in there. And so it took x squared, it's cube, sorry. 2 cubed is 8, minus y cubed is 27, that gives you minus 19 with that z in there. Okay, so that's the substitution command. Could be done, you know, when you're manipulating algebraic expressions. And the next one is evaluate known forms. What this produces is this. Now, this has particular applications in calculus in the following way. I'm going to get ahead of myself and do a derivative. Differential of x cubed minus 1 comma x. Control enter or shift enter. The derivative of x cubed minus 1 is 3x squared, right? But suppose that you want to present this before it gets evaluated, then you put an apostrophe and type diff x cubed minus 1 comma x, shift enter, and it shows the derivative before it gets evaluated. But now you want to evaluate the derivative. You could either go ahead and type the whole thing as did, or you can say f percentage nouns, shift enter. Okay, or if you do it in a single line, you could put x cubed minus 1 comma x, right arrow, semicolon, f percentage nouns, shift enter. And so in one line you provide the expression before the derivative, and then you get the expression after derivative. Same thing with integral. If you do integrate 1 over parentheses x squared plus 1, for example, right arrow, comma x, that gives you the arctangent. But you could also type apostrophe integrate parentheses 1 over x squared plus 1, right arrow, comma x, right arrow, semicolon, f parentheses the percentage symbol followed by nouns. I don't know what it works. This is obviously reference to the previous result. Nouns, I believe, refers to the fact that you're going to do it symbolically. So you go shift enter, give you the integral of 1 over x squared plus 1 dx is equal to the arctangent of x. And that's the application of this evaluate known forms option. The next three had to do with specifying some operations like algebraic true. The next one is algebraic equality. Enter an equation for rational simplification. So for example, as you go x squared plus 1 equal x minus 3. Simply moved everything to the left hand side and it makes the whole thing equal to 0. So that's basically what that is. This one, I'm going to have to skip that one at this point. But the algebraic equality works for that. And the modulus computation, I don't want to get you confused with that. I'm going to skip that one too. And so these are the commands that show up in the last part of the simplify. The substitute, evaluate nouns form, algebraic equality is the only three. The other two we'll just ignore at this point. And with that, we finish this video number 3 on algebraic simplification.